Right, so we're going to be talking about area of parallelograms and triangles today. One thing you need to know is that area is in square units. And what that means is what you're finding is actually how many 1 by 1 squares fit into a certain surface area. Okay. So area of a square, it's really just a bunch of little squares, depending on how big the sides are and how of that square. The area of a square is the length, the square of the length of its side. I also think that you're used to doing length times width, and another way you could say it is base times height, or little. It doesn't have to be big B, little b times. I should use little b, because we'll be talking about big B's in the future. All right, so if the area is base times the height, you just take a square, whatever its dimensions are, and say it was 4 inches by 4 inches. Then what that would mean is that the area is, you can do 4 squared, or you can do 4 times 4, means the same thing. So the area for this figure would be 16, and then your units would be in square inches. Okay, rectangle is much the same. If you have a rectangle, the area is base times the height. Area of a rectangle is the product means multiply of the base and the height. Or you can use length times width, but I typically will say base times height all the time. If you had a rectangle, say that was 2 meters or just 2 by 9, its area would be 2 times 9, which would be 18, and then you'd have to write U squared with a U if it didn't give you any label, or you're going to write 18 square units. You might see this as a written answer in some of your standardized tests that you might have taken. 18 square units. Now, I say square units, and you might be thinking, well, that reads units squared, doesn't it? Well, not really. They are square units. They're 1 by 1 squares. But I know that you guys will probably be saying in your heads square meters or meters squared, because that's how you write it. Okay, because you write the little 2 up there second. I have a blank page in here because I want to show you where, well, I'll show you that in a minute. I'll go back to that blank page in a minute. The area of a parallelogram, I'm going to do it now. See a rectangle? I want to show you why the area, we already just discussed that you don't have to write this at all. Just watch for a second. Area of that thing was base times height, right? Well, if I chop off a corner and I slide it over here, it went too far because my pen got strange, and I stuck it on over on this side instead. What shape do I have now? I have a parallelogram, don't I? And it's got the same area formula. It's base times height. That's why. So, oops, wrong way. Area of a parallelogram is base times height. Same as a rectangle or a square. There's your base. There's your height. The area of a parallelogram is the product, multiply, of the base and the corresponding height. Base of a parallelogram, either pair of parallel sides of a parallelogram are bases. So the base can be at the top or the bottom. Doesn't matter. Even if your parallelogram is turned in a strange direction, like this. Now I have the base here. It's on the side. Well, this is a base too. And the height would actually be inside the figure. That would be your height, because that would be the line. It says the height is the perpendicular distance between any 2 parallel sides. The parallel sides are the bases, and the height is that thing with the little right angle on it. Perpendicular distance between the bases. Okay, next we have triangles. I'm going to go back here for a second, and I'm going to talk to you about the shapes again. I'm going to draw 3 shapes. Oh, Lord, that was a horrible start. Okay, got a triangle. I mean, that's not a triangle. That is a square, rectangle, and parallelogram. Watch. We said that the formula here was area is base times height. We said the formula for this was base times height. We said the formula for this was base times height. They were all the same. And now I'm going to chop them in half. Well, let's go that way, and then I'll do even another one. Your heights can be drawn this way as well. Oh, that was just not even what I wanted to do. I'm going to chop this one in half also. But I'm going to go the long way. Sometimes you can draw your heights on the outside of a figure. This thing, the whole thing would have been base times height, but if you cut it in half, what did you just do to the formula? So that's a triangle, right? It's a little right triangle. The area of that little right triangle is base times height, but you had chopped it in half. So it's base times height divided by 2. I chopped this one in half, so the area of the triangle would be base times height divided by 2. I chopped this thing in half, so this little triangle right there would be base times height divided by 2. I chopped this one in half. This would be my base. This triangle's area would be base times height divided by 2. Right? Yeah, that's where that formula comes from. So it works for any triangle, no matter what the shape is. And here's one that I did draw. That's an area of the triangle. And let's draw a few more down here. So in your notes, this would be your height, this would be your base. That's an example of a drawing of a triangle. Let's see, we could have an obtuse triangle. Got a big fat angle. And that'd be the base. And then the height would probably be drawn, it would be drawn on the exterior. So that's all dashed. That's your height. That is a right angle right there. Okay, so the area of a triangle is 1/2 the product of the base and its corresponding height. Like a parallelogram, the base can be any side depending on which way you situate it. So let's say I took that triangle right there and I flipped it over. Maybe I would want to look at the height inside here. And this would be the base. I kind of flipped it over. But the point being, sometimes the height's on the inside of the triangle, sometimes it's on the outside, and sometimes it's on the triangle, part of it. Okay, let's do some examples. Okay, we got a square. All right, area, 3.4 times 3.4. You grab your calculator. This is where you start developing your physical memory. 3.4 times 3.4, or you could just hit 3.4 squared. We should be calculating away, 11.56. And that would be in square meters. We are also going to be finding the perimeter of the figures. How many sides this has? 4, and all of them are 3.4. Because of those slash marks, it's a square. 4 times 3.4, 13.6 meters. Label, label, label. It says label on everything. Don't forget your labels. It's going to count against you more in this unit than it did in the last. All right, more 11.1 examples. Be sure to, everything says that. Label the answers. Find the area of the parallelogram EFGH. Well, it's base times height. I've got a base of 30. I've got a height of 18, if you feel like labeling them. So it's 30 times 18. We type 30 times 18 on our calc. And bingo, you'll probably beat me to it. $540. And that you need a label of square meters. M squared. meters squared. Area of a triangle, you jot down the formula. It's base times height divided by 2. The base in this one is 24. The height is the 28. So we're going to do 24 times 28 divided by 2. And you can type that all at once. I got 336. And that would be in square meters as well. Okay, no more examples. Number 3, find the area and perimeter. Okay, now it's find the area and the perimeter. I'm ready to find my area because my base is 22. My pen stuck. One moment, please. There we go. Base and your height is 14. So I've got 22 times 14 divided by 2 for the area. Okay, I'm a little bit slow on that. 154. And you label it square feet. Or you might be saying feet squared. That came out crazy. Tongue twister. All right, I was moshing my letters in weird places. All right, now we got to find the perimeter. Uh-oh. Well, so far I only have 34 plus 22. What am I missing? I don't know what you would call that, but I'm missing a side, right? I don't know this. I need it. So to find that, I'm going to call it x. And I can use Pythagorean theorem because they told me the height's 14 and this other leg is 8. So remember, leg squared plus leg squared equals hypotenuse squared. Over and over and over we've done. That's like that's so important, that theorem. Oh my goodness. So I got 14 squared plus 8 squared equals x squared. Grab your calc. I probably should ask you guys because you're probably getting it so much faster than me. 260. And then we got to take the square root of it. And that is 260 in case you couldn't read my letter there, my number there. Square root of 260, I forgot what that is. 16 point what? 12. So probably if we went to the 10th, 16.1. All right, and that's what we got to add on here. All right, so add those all up, please. And tell me your total. Okay, I added them up. I got 72.1. Is that right? And that would be in feet. All right, moving on. Number 4. For this one, the perimeter is really easy because opposite sides are congruent. So you'll have 2 5s and 2 4s. Don't make the mistake of only adding the 2 numbers that are on there. That's 11 plus 8, that'd be 19. And it's in feet. All right, now, I need to know the height. I have to use special right triangles or trig to get it. I tell you what, if you learn the special right triangles, it's faster than doing the trig. So I'll give you a quick reminder of the pattern that we were tried to learn, but everyone was not successful with it. You had 30, 60, 90, and your short leg was n. Your long leg was n times the square root of 3, and the hypotenuse was twice the short leg, 2n. All right, so in this picture, 4 is where the 2n is, so what's n? 2, and this would be 2 root 3. Hypotenuse 4, cut it in half, that's 2. The long leg would be 2 root 3. So the height is 2 times the square root of 3. Now, I don't mind if we check what that is in decimal form. That's exact form when you write 2 root 3. That's 3.464. Now I'm going to show you something again. I proved this to you before. Let's say you wanted to do this without doing the special right triangles. Your other option is by trig. This would be the triangle you have. You're trying to find the height. So what is the side we need in relation to the 60? Is it opposite, adjacent, or hypotenuse? It's opposite. And the hypotenuse is where the 4 is. So opposite and hypotenuse, you better know, is the sine. Sine of 60 equals opposite h, the height you want to find, which is not I'm not using h for hypotenuse, guys. It's the height of the figure for the formula we're doing. And then 4 would be the hypotenuse of that triangle. So then you would calculate it. 4 sine 60 equals the height. If you type 4 sine 60 on your calculator, you get exactly what we got when we did 2 root 3. Finding this, figuring out 2 root 3 was much faster if you understand it. If you don't, then you're going to have to do the trig. Okay? You gotta be able to do one of them, else that's problems out the window. All right, so we got 3.46 as a decimal. So the area, you got a base of 5.5. All right, so 5.5 times 3.46. Go ahead and calculate. I guess I could just type times 5.5 on my calculator. You do not divide by 2. It's not a triangle. You get 19.05. If you rounded it off, you probably did 19.03. If you had rounded this to 3.5, it would have been a little bit different. Don't sweat that, okay? And that would be in feet. Squared. Square feet, feet squared, however you want to say it. All right, moving on. Number 5. Now we're going to do a work backwards problem. The base of a triangle is half of its height. So its height's the biggest. I'm going to make a triangle. I don't know what kind of triangle it is. But it said the base is half the height. So that means the height is how much compared to the base? If I make the base be x, how big would the height be? 2x, right? 2x, because it says half of the height would give you the base, so half of 2x would be x. We're good. All right, we know the area is base times height. They're telling us the area is 100. That's an A value, so I put in 100 for A. Oh, wait a minute. I have missing something in my formula, and no one said a word. What's wrong with my formula? Yeah, it's a triangle. We got to divide by 2. Okay, so I'm going to start back in here. I'm going to put my 100 in for A. I'm going to put in x for the base and 2x for the height. And then in the formula, it says divide by 2. Well, can't the 2's cancel? Or maybe you don't see that. 100 equals x times 2x would be 2x squared divided by 2. I hope you see the 2's canceling now. Otherwise, you could multiply by 2, then divide by 2, right? It's up to you. Maybe I should do that because that'll help you if the number right here isn't a 2. I mean, 200 equals 2x squared. I don't know. It just was kind of like going backwards. Divide by 2, no, 100 equals x squared. We got to take the square root of 100. And that gives me 10, which would be my base. And this was in centimeters, so this has to be in centimeters. And the height is twice as big, so it would be 20 centimeters. Okay, let's try another work backwards problem. Anybody still need this? Okay. Oh, and these were just where your answers. They were in centimeters, I think, right? All right. All right, another backwards problem. The height of a parallelogram, oh, got a tall pair, is 3 times its base. Oh no, I'm just making a big old parallelogram. Don't know why I made it so ginormous, but I did. All right, the height of the parallelogram, and it's not going to look to scale at all, based because I stretched it, is 3 times its base. So if I let the base be x, then the height's 3 times that, 3 times x. The area of a parallelogram is base times height. It says the area is 432. So I'm going to put 432 for A. I'm going to put x for base times 3x for height. So I've got 432 equals 3 times x squared. X times 3x would be 3x squared. What am I going to do now? Divide by 3. Lexi, all right? Okay. Divide by 3. Is that 144, guys? Please check 432 divided by 3. Okay, then take the square root. And we get x is 12. All right, so we go, and that's our base. If you look back at what we drew, our base is 12. This was in inches. And our height would be 3 times 12 inches, which would be 36 inches. Okay, that's it for our notes for today. So let's go to our packet. You've got all your formulas in the very beginning. That's all this stuff is. Let's go to some concrete problems and do some more together. This thing has a base of 18. I need to add that 10 and 8. So I'm ready to do the area because it's base times height. So I'm just going to do 18 times 16 and get that problem, part of the problem done. Okay, I got 288, and it would be labeled square feet or feet squared. All right, now I'm going to try to find the perimeter. I know if there's 18 at the bottom base, then the top base is also 18 feet. But I don't know this length, which is the same as that length. So I got to figure it out. I've got a height of 16, and I know this is 8, so I've got a little right triangle here. This would be my hypotenuse. I'm going to call it x. So x squared equals 8 squared plus 16 squared. Can you tell me, please, what 8 squared plus 16 squared is? 3 what? 320, okay. And now we're going to have to take the square root. And I know that's a decimal. About 17.9. All right, so if we got 17.9, we've got 2 of those. Plus we have 2 18s. We got to add all those up. So please add. $71.8, and that's in feet. Number 2. Oh my gosh, this one's so easy. Perimeter, 4 times 1.6. Was that 6.4 centimeters? 40 plus 20, yeah, 6.4. And then the area, just 1.6 times 1.6, or 1.6 squared. And that's 2.56 square centimeters. All right, I'll start writing the formulas here. Find the perimeter in the area. To find area, it's base times height. Do we have the base and the height? Well, no, I do have the base. I need to find the height. I can do the perimeter fast because all of these sides are said to be equal. So I just got 4 times 24. So that's easy. That's 96 inches around the outside. Okay, and now let's figure out the height. If there's a 60-degree angle in this corner, since it's a parallelogram or a rhombus, opposite angles are congruent. So that would be 60 up there in that upper left corner. I would use special right triangles. That's what I would do because it's so much faster than trig. If the hypotenuse of this little right triangle here is 24, then the short leg is 12, and the long leg is 12 root 3. So the height is 12 times the square root of 3. You can just type this, or if you don't see that, I can do it again where I show the sign. If I didn't know those, then I could have said the height of this thing, opposite over hypotenuse, or you want to call that x so you don't screw it up, opposite over hypotenuse would be the sine of 60 equals x over 24, and you would calculate 24 sine 60. And whatever that is, it's about the same as 12 root 3, or it is the same exactly. All right, 20.78 or 20.8 if you went to the nearest tenth. So either way, we're going to get about the same answer. And if you're a tiny bit different in your decimals because of rounding, I will not penalize that. What was, 20.78 or 2 root 3. I'll show you how they are the same. Times 12 root 3. Me. To give us the same answer, almost identical, except one is rounded already within the problem. This is the best answer, 498.8. And that would be in square inches. If you have a little bit different, don't worry. All right, number 4, everything's provided for us. Opposite sides are congruent, so we have 2 20s and 2 10s. You could do 2 times 20 plus 2 times 10 to get your perimeter. That's kind of a quick way to do it. 40 plus 20 would be 60 inches around. Area is base times height. You've got a base of 20 and a height of 8. So that's 160 square inches. Now that one was really easy because everything was given to us. We didn't have to find anything. We just did it. But of course, they're not all that easy. And then we get to, this is a really good example of some real life geometry. Did I go too fast for anybody? Or am I going too slow? Too fast? Oh, okay. Tile floor. This would probably be a pretty cool floor once you put it together. You can make a lot of different patterns using it depending on what sides you put together. But you got a bathroom tile floor is made of black and white parallelograms. Each parallelogram is made of 2 triangles with the dimensions as shown. So they're just giving us the dimensions of all the shapes here. So where's this 7? On the real figure would be right there. So they're just trying to show us dimensions. And this 11 would have been down here. Okay, so what's the height? And that number would be the 6.7. So to get the perimeter, I think it's easier to look at the whole shape because that's 11, that's 11, that's 7, and this is 7. So we'd have 7, 11, 7, and 11. Sounds like a convenience store. Has anybody ever heard of a 7-Eleven? Anyway, that's when I was a little kid. That was my first place I got a Slurpee and bought my... Anyway, they used to not have gas at them, and they were just a little like the Fast Marts that you see now. They're very similar to that. And I had them, they had them all over Florida. All right, anyway, 7, that's what, 18 and 18, 36 centimeters for my perimeter. All right, now to do my area, I just need to know the height is the 6.7 and the base is 11. So we just need to do 11 times 6.7. Can someone do that, please, on your calculators? How much? It's only 73.7, okay? And square centimeters. Be careful with your labels. Okay, now we get a challenge problem. I will not be testing you on this type, but I'm going to show you how to do it. We got the height of a parallelogram is 5 feet more than its base. So if I let the base be x, if the height is 5 feet more, how could I represent the height? What would 5 more mean? Pardon? Would it be 5 times x, or would it be 5 plus x, or x plus 5? Say 5 more. If you have $5 more, that means you would add on 5 to what you have, right? So it would be x plus 5, not times. Right? So this one's going to be a little weird. So we got the area is 66. All right, and we know the area formula is base times height. So I'm going to plug stuff in. I'm putting in 66 for A. I'm putting in x for the base and x plus 5 for the height. Some of you are in Algebra 2 concurrently with geometry. You should know what's going on right now. You have been doing a bunch of this all year. X times x squared plus x times 5, 5x. I distributed. And now I would set it to 0 by subtracting 66 from both sides. I get x squared plus 5x minus 66. Back in Algebra 1, you might remember this. You did something called factoring or unfoiling. Remember that? All right, I want to remember diamonds. What? Okay, all I want you to do is tell me some numbers that multiply to give you 66. Give me some numbers. 11 times 6. Can you make a 5 out of that somehow by adding and subtracting? Can you get a 5 out of an 11 and a 7? Yeah, I mean, it's 11 and a 6. I'm stuck on 7, 11. All right, that would be if you want a positive 5, so you'd want this 11 to be positive and the 6 to be negative. If you do 11 minus 6, wouldn't you get 5? Okay, so the middle number here is a 5. You do x times x is x squared. You do 11 and 6 because 11 times 6 gives you the last number, 66. You need it to be positive 5x in the middle, which comes from the product of those added. And so 11 times x would be positive, and you'd want the 6 negative, so you'd get a negative 6x. That would give you 5 in the middle, 5x. All right, anyway, we then take each of these factors, and we set them to 0 and solve them. So you would subtract 11 and get negative 11. You would take x minus 6, set it to 0, solve it, and get 6. And which of those answers would fit the parallelogram? Think about it. Which answer works for a parallelogram's length of its sides? The only one works is the 6. This does not work, so it's called an extraneous solution. All right. Now, you've heard this before in Algebra 1. It's just been a long time. So I'm not saying I would have put a bunch of these or anything on test, but this one was pretty reasonable to be able to figure out that. But I've not been teaching factoring, so I won't put it on a test. But I am exposing you to it. You will need to be able to do this next year. The base then, we found out is 6. And this stuff was in feet. And the height, 6 plus 5 is 11 feet for your height. Okay, let's do a little more. We've got 15. Okay, this would be a right angle because that is a right angle on the right. We need to find this height so we can do the area of the triangle because this would be its base and this would be its height. So that we're going to do by Pythagorean theorem. H squared plus 3 squared equals 5 squared. 8 squared plus 9 equals 25. Do you see how we're supposed to be proficient with the Pythagorean theorem? We've done it so many times. Subtract 9, h squared equals 16, and then we take the square root, and we find out h is 4. I don't know why I wrote 14. I think I was thinking about writing the answer of 4. So h is 4. All right, so we got 4 for the height. We can do the area of the triangle now, because the base is 15 times the height 4 divided by 2. Area is base times height divided by 2. That would give us 60 divided by 2, which is 30 square centimeters now. Okay, next. I've got 4 for the height. I got 15 for the base of the triangle. I need its perimeter. I am missing a side still. And that is the hypotenuse of another right triangle. I know the legs. So I call this x, and I'll tell you x squared equals base 15 squared plus 4 squared. I am doing Pythagorean theorem yet again. X squared equals 225 plus 16. And that's 241. All right, find out the square root of 241, and we'll be ready to do our perimeter. What was that? 15, 6, what is it? 15 point what? 5, okay. And then perimeter, we're going to do 15.5, we just found, plus 15, plus 4. So that's 34.5 centimeters. Okay, a couple more. Got number 8. Oh boy, this is a lot of Pythagorean theorem, have you noticed? We need to do the perimeter. We're going to need to find that thing right there, which is the hypotenuse of that right triangle. So x squared equals 11 squared plus 40 squared. I don't know what that is. 11 squared plus 16. I guess I'll grab my calculator. Although I know you guys are probably beating me, as I always say. I just type something goofy. 1721, we're going to have to take the square root of that. 41.48. Okay, so now we can do our perimeter, 11 plus 40 plus 41.48. There is a number we did not need in this picture, which would be the 15. Because, well, add this up, you got 52.48, 92.48, or 92.5 if you went to the 10th. Since it didn't, oh, it says round to the nearest 10th. So I should have done that at this point. So I round to 92.5. Right, and then the area, this is your base, 40. Your height is 11. Area is base times height divided by 2 for a triangle. So we need to do 40 times 11 divided by 2. That 220? 220 square inches. Okay, to get the, oh, this is going to be tons of fun. We got to do the, we've got to do Pythagorean theorem twice. I'll find this first if you want. Actually, I could do it by special right triangles, but it'd be 9 root 2. I don't think you probably want to do that. So 9 squared plus 9 squared, if I want to find this piece. That's 81 plus 81, 162. Take the square root. Square root of 162. Ugh. Would have been nicer to write 9 root 2. 12.7. Let's just go to 12.7. Sorry. Because I got to do it again. I got to find this now. Okay, and so I have to use the ginormous right triangle here. So this side down here, if I add 13 and 9, isn't that 22? So I've got a big old right triangle that has 9 for a leg and 22 for a leg, and I want to find this. I'll just call it y. So y squared equals 22 squared plus 9 squared. I'll go for my calculator. I can hit the second square root of, no, I shouldn't do that. Well, what the heck? 22 squared plus 9 squared? Let's do it all at once. Are you guys getting 23.8? Right? All right, finally, I can do the perimeter. I've got 23.8 plus 12.7 plus 13. I'm only doing the gray perimeter. 23.8, 12.7, and 13. Somebody tell me what that adds up to. How much? Thank you, 49.5 centimeters. And then area would be base. Oh, what's the base of this thing? It's not the 22. It's only, yeah, the 13. Times the height, which would be your 9 divided by 2. It's going to be a decimal. I know that. What is it? 58.5 on your calc. Awesome. All right, square centimeters. All right, good job. Please practice some areas. We'll do some more with it tomorrow, as well as add on the area of kites, trapezoids, and rhombi.